Good morning, everybody. Excuse me. Good morning, everybody, and welcome to the fifth Recolight webinar this year. Today, we're doing deep dive into life cycle assessments and environmental product declarations. And we have a excellent speaker today, Max Robson, who is environmental metrics and training manager at Recolight, and he's an expert in all things sustainability measures. We'll also be joined by the Recolight Chief Executive Officer, Nigel Harvey, afterwards, and then we'll be taking your questions and comments, and we'll answer as many of them as we possibly can. As I said, this is our fifth webinar this year. We've had four others, one on BS 8887, the remanufacturing standard. We did one on the waste regs for lighting manufacturers. We did one on designing sustainable luminaires. And we did one on LCAs, again, specifically back in January. And all of those you can watch again, fast forward, stop, and all that type of thing. Just go to recolight.co.uk, follow the links for the webinars, and you can see all those as well. This one too will also be eventually archived like that. So you should get the slides and the links tomorrow lunchtime. If you can't see it, check your spam folder. So we will be, as I said, we'll be recording this and it will be posted tomorrow. You'll get your slides via MailChimp. And I say this all the time. If you want to ask a specific question or comment about the content, please use the Q&A box. That's the one that Max, Nigel, and myself will be looking at. Use the chat box to speak to my colleague Suzanne, who will be dealing with all the admin, any technical issues. Just pop those in there for her. We do lots of stories and interviews about sustainable lighting on the Circular Lighting Report. You can navigate to that via the Recolight website. You can also follow us on LinkedIn. Just search Circular Lighting Report and then just give us a follow. We've lots of followers. We post stories nearly every day, and just lots of thought leadership and lots of interesting stories about what the people are doing in the sustainability space. And of course, we have our big flagship event, Circular Lighting Live, coming up on September the 25th. So please make sure you got that in your diary. It's a one-day exhibition and conference. We've got 2 tracks. We've got 8 sessions. We will be doing a full session on environmental metrics. We will have an update on version 1 of TM66, which is being worked on at the moment. We will have an update on the IELD's life cycle assessment, and Max will be presenting as well about EPDs. So, and also we'll be looking at lots of other things such as remanufacturing, Cat A waste, etc., etc., and lots of circularity ideas, lots of new business models. We got some surprise speakers, so lots of good stuff. And also an exhibition where you can see lots of interesting products and innovations and initiatives. And of course, I should say it's also free to specifiers. Right, on to the business at hand. So demystifying environmental product declarations and life cycle assessments. Max.
Ooh. Thank you, Ray. Let me just share my screen a second. And then works. Sorry, bear with me 1 second. Try again. There we go. I assume that's the wrong way around. Can you see my slides?
That's fine.
You can.
Yeah, that's
Yes.
good. That's
Okay.
good. Yeah.
Thank you. Sorry about that. Okay. Thank you, Ray. And good morning, everyone. Thanks for joining our webinar this morning. Here to talk more about EPDs. My name is Max Robson. I'm the environmental metrics and training manager at Recolight, and I spearhead the Recolight LCA service. but today we're going to talk about EPDs. So, just a brief outline of what I'm going to talk about today. So I'm going to give more of a reminder of what an EPD is to start with. And then I'm going to go into interpreting the results from an EPD and explaining what a scaling table is that you can use for EPDs. I'll then go into kind of the strategies as to how you can obtain an EPD. And that will feed in really nicely into me talking about some of the service offerings that Recolight have, notably highlighting this new one-off EPD service that we're now offering the industry. So Ray's already mentioned this. We have various webinars that we've done this year so far. We have already done a life cycle assessment for lighting products webinar back in January. And I'd highly recommend kind of looking back over this, go to the Recolight website and have a look. This past webinar, I spoke a lot more about the details of LCA, the details of EPD, and those sort of metrics, just to get a broader understanding of how these metrics kind of work. To start with today, I'm going to kind of go back over some of those slides just as a kind of reminder, and then kind of expand on a couple of aspects. But yeah, I'd highly recommend going back and having a look. So when we're thinking about environmental metrics, what we're really doing is thinking about how we're measuring the impact that we're having on the environment, because ultimately it's the impact on the environment that we're wanting to trying to reduce. And it's no secret that the built environment has quite a significant impact on the natural environment. So just highlighting the kind of the hotspot that the built environment is. Here you've got a study by the United Nations Environment Programme that shows that around 37% of energy-related carbon emissions are associated with the built environment, and the fact that around half of all extracted materials are used in the built environment, which is a heck of a lot of material when you think about it. When we think about lighting more specifically, we think a lot about the use phase, which quite rightfully the consumption of electricity, and there's evidence that shows that we know around 50% of all electricity consumption can be attributed to lighting alone. So lighting is obviously responsible for a very large portion of our kind of impacts as an industry and the use phase as well. But it's not just about the use phase. This is another slide that I presented in our last webinar. When we think about lighting, so I've got kind of a diagram here of the life cycle of a lighting product, and it goes from kind of raw materials, go through the design process, all the way around, and hopefully back round once it gets disposed for the raw materials to be used again. But I just highlight here that in orange the use phase, so the kind of energy consumption phase. Over the course of a product's lifetime, kind of all the many years that stack up in its use phase, the energy consumption can amount to quite a significant impact. However, it's not just the use phase that we're concerned with. It's not just the operation of the luminaire that we're concerned with. It's also the embodied impact. So it's kind of everything else that goes on in its life cycle. And you can see early on we've got quite a high kind of upfront carbon footprint. A few smatterings of kind of embodied carbon during its lifetime, so that could be for repair or kind of remanufacture, and ultimately the kind of disposal at the end as well, and that actually constitutes a significant footprint as well. This is kind of an illustration, I'd say, that's the split between operation embodied and embodied now, but what we're the kind of ideal situation is that we see product innovation and decarbonisation strive towards this kind of lower total here, and that the decarbonisation of the grid means that the use phase will have a lower carbon footprint, and we innovate our products to have to be more efficient in their material use, have kind of more lower intensity materials as well, such that the embodied side of it is lower too. But to achieve this sort of product innovation, we need to measure, we need to target, and we need to reduce all these impacts. And so to do this, we need metrics, and that's where EPDs kind of come in. So briefly, what is an EPD? So an EPD is an independently verified and registered document provides transparent and comparable information on the environmental impacts across a product's life cycle. At its core, an EPD is essentially just a document. It's just a declaration document, and it would typically, well, EPDs kind of look different potentially from different manufacturers and different providers. They're essentially they are essentially providing the same information. I've got some screenshots here from a tiling EPD. So that's the front page. Then the second page, which is just a bit more about the EPD itself, who verified it, how it's been made, the standards that it follows. Another screenshot here of the process flow map involved in the product life cycle, and ultimately the environmental impact results, which will typically come slightly further down in the EPD documentation. So an EPD is a verified and registered document. So you have a program operator will manage the registration of that document. And so here, this EPD I've taken from the EPD Hub website. That's the program operator, and you can visit their website here, which has the EPD database, their EPD database, for all the EPDs that they manage. And it's supposed to be a transparent and comparable set of information so that you can understand how a product performs on the environmental side. So ultimately, it's a multi-page document, but this table here is the core set of results that that you'd be looking for in an EPD. And I want to highlight here that the numbers contained within that table are calculated using a methodology called lifecycle assessment, which I'm sure many of you have heard of as well. So lifecycle assessment is a methodology used to quantify global warming potential and other environmental impacts through the life cycle stages of a product or a building or a system. It's a tool that's very flexible in its scope, and you can use it for all sorts of different things. As I say, buildings, systems, processes. But essentially, when you're using a lifecycle assessment, LCA, for the sake of an EPD, we're talking about a product, and it has to fit a certain set of criteria so that it can feed the information into an EPD that's appropriate for the standards that we're concerned with. So very simply, the LCA process, you need to consider particularly for luminaire products, you need to think about different stages of the life cycle, and think about all the inputs and the output flows of materials and energy that kind of go into its life cycle. So if we start from raw materials, you've got things such as packaging and materials that go into the product. And then at the production stage, you may well have energy inputs. That can be gas, that can be electric, that can be generators, etc. Potentially water and other ancillary inputs as well. When we think about electrical products such as luminaires, the operational energy use is obviously a very important stage, as I've highlighted earlier. But they've also got impacts associated with end of life. So there may well be impacts during the process of dismantling the product, taking it off to recycling and landfilling as well. Once you've got all those inputs and outputs and you've got an inventory, and in its most basic sense, an LCA would take each of those inputs, run it through a calculation to convert that into some sort of impact. So in this case, I've got material A, run it through a calculation, and you get a kilograms of CO2 equivalent. You do that for all the different materials that are going into this product's flow, and for different impact categories as well. This whole process can be quite onerous, and you have quite a few calculations that you have to do. So it's typical that you'll be looking to use the software to do this, to help you do this. But ultimately, you return a set of results that's going to be quite comprehensive that you would then be distilling into an EPD results table. So I've got a screenshot here of a results table for an EPD for a linear luminaire. Excuse me. And you can see that it's quite comprehensive. So just bear with me as I try and explain this results table to you. So this is the environmental impact data that's presented in the EPD, and it's called the core environmental impact indicators. There are lots of different indicators of impact categories that you can get out of a life cycle assessment. But to comply with EPD standards, there's a certain set that are presented here. And you can see that this set complies with the EN 15804 building products standard, which is the one that we are most concerned with. Now, along the top, you can see we've got A1, A2, A3, all these codes going along, Bs and Cs. And if you're familiar with the TM65 methodology, you may well have seen this before. But it's a standardized way to a standardized nomenclature for the different life cycle stages of a product. So if I add labels up at the top here, we're going from A1, which is material extraction. You've got transport, you've then got the manufacturing stage, all the way through to transport to get to construction. Bs are all the use stage. So most importantly for us, the operational energy use is B6. And then Cs is end of life and the different processes as well, all the way down to disposal. So that's the different life cycle stages. And then down the side here, we have impact category, because there are various environmental impacts associated with manufacturing a product. The one that unsurprisingly takes the limelight is GWP, which is global warming potential in the unit of kilograms of CO2 equivalent. And it's this line here that does take all the limelight. But you can also expect to see in an EPD that this will be broken down into fossil, biogenic, and land use as well. And there are other impact categories reported too. So, for example, here we have ozone depletion, acidification, smog, water use, lots of different impact categories. So this table we have life cycle stage along the top and impact category down the side. And what this means is that the EPD user can actually interpret these results and use these results how they need. They could just look at the operational energy use phase if they wanted to. They could just look at the manufacturing phase if they wanted to. Or they could say, for example, they want to understand the amount of water used during the manufacturing process. So they go to the A3 manufacture stage, run down to the water use, and they see the number 1.78 E minus 1. So now is a good point, a good stage to point out that in EPDs, a lot of, well, pretty much all of the information is reported in scientific format. And so here, this 1.78 E minus 1, all that means is 1.78 times 10 to the power of minus 1. And so this number in reality is just 0.178 meters cubed of water. So I hope that kind of gives you a flavour of how to interpret the set of results, because it can be quite imposing when you first look at it. But it's also worth highlighting here that this particular set of results is for one product. You can do it for an average of products, but you will often see it just for one product. And I want to highlight here that you don't necessarily just need to do an EPD per product. You can actually group products into an EPD by the use of what's called a scaling table. So let's say, for example, the results on the previous slide that I presented to you are for luminaire A. But in the same product family, you've got luminaires B and C, and these draw different amounts of power. So I've just got some back of the envelope calculations here to show the carbon, basically the carbon footprint per hour use of luminaires A, B, and C. And you can see that because they draw different amounts of power, they're going to have a different carbon footprint. And so how do you reflect that in an EPD if you want to make sure that this EPD can be representative of luminaires B and C as well? Well, you can do this by using a scaling table. So you can say in the use phase, the B6, which is the operational energy use, can be scaled accordingly. So I say in this instance that luminaire A is the reference product, which is what the table on the previous slide was referring to. But then if we wanted to understand the B6 impacts associated with luminaires B and C, you would then have to scale the impacts by 2 and then double them again for luminaire C. To add a little bit more to this scenario, I am making up the scenario in that luminaires A and B are a luminaire of a fixed length that have two different power usages. But then luminaire C is maybe a larger version, so a longer linear luminaire. And in this instance, we know that the manufacturing, this has implications to the manufacturing impacts. So now if we take the A1 to A3 scaling, so if I go back to the previous slide, that is A1 material extraction, transport, and manufacture, so the kind of the stages that kind of cradle to gate. Those impacts will be the same for luminaires A and B because they're the same length. But then if we've got luminaire C, which is in the part of the same family but a larger variant, I've said here that you actually have to, I've worked out that you have to multiply those impacts by 1.7. So what does this mean in reality? So this means that an EPD user can then look at the use phase for luminaire A, and it can find the global warming potential total and the operational energy use, that B6, is 6.27 times 10 to the power of 2. So that's for luminaire A, which is the reference, but for luminaire B, you have to double it, and then luminaire C, you have to double it again. That same process can then be applied to the manufacturing stage, so A1 to A3 scaling. Handily here, we've got A1 to A3 total provided to us. So that is 2 times 10 to the power of 1. That is for the reference product, luminaire A. And we know that luminaire B is the same, and luminaire C, we just need to multiply it by 1.7. And so it's a really nice way that the EPD user can use the information in that EPD to extract global warming potential for other variants within the same family. And I just wanted to highlight that it's not an EPD per variant. So just taking a step back now and thinking about the EPD process. This is something that I've highlighted in the past as well. And I've already kind of alluded to the fact that you start off with an LCA study. So you go through the process of understanding the different stages of the life cycle, and you conduct an LCA study. The results of which can then be distilled into the EPD report, as I said earlier, into a table that looks somewhat like this. And then that documentation will then be sent to a verifier who will ensure that you've complied with the relevant standards and program operator rules. They will determine that it can be that it's verifiable and give it a big green tick, and then it can be published as well. In reality, I'm kind of using a bit of artistic license there, because I would say that there's an extra stage early on where you need to collect the data. Data is definitely required in the process of conducting the LCA. But I just want to highlight it here because it's always going to be the first process. It's always going to be a process that the manufacturer is going to have to be involved with. And I've had conversations within the industry that of companies that aren't necessarily wanting to look into EPDs right now, but know that they need to collect the data, and so might well just be doing that early doors in preparation for this whole string of steps that they see are incoming. And ultimately, you can use the EPD as it's a verified environmental declaration. You can use it to market your product. You can use it for sales and what have you, knowing that you've got a robust set of data that's verified as well. So that's the EPD process, and there's a couple of ways that you can actually go about undertaking this EPD process. So the first way that you can go about it is to outsource the entire process. You can get a consultant to do it for you. An LCA consultant, will be well versed in all steps 1, 2, 3, and 4, and will be able to take on the brunt of the work. That's with the understanding that you'll be able to provide the data. And the other option is to conduct the EPD process in-house. And there's I'd argue that there's two kind of ways about this. One is to use an LCA specific software, so that will be a technical software. As I say, LCA is a methodology that can be used with really quite flexible scope. And so it would often be a technical software that you can create a model out of, populate that model with the relevant data, and then you can use that data to create your EPD report, which you can then send to your verifier to then get published by a program operator. The other in-house approach is to use an LCA/EPD software. Now, this can be a software that has may well have a model kind of created for you, and all you need to do is tweak it to make sure that it's appropriate to your product category, i.e. in this case luminaires, and you populate the data, and it will then pre-populate a kind of an EPD report template. And so instead of getting just a huge set of results out at the end that you need to distill into an EPD, you would actually get the EPD documentation out straight away. Now, Recolight are partnered with One-Click LCA, and I think this is a good point to kind of highlight that this is the sort of software that One-Click LCA can provide. And so their tools are very EPD orientated, so they're kind of EPD generator tools. But they also have the added benefit that One-Click LCA have a relationship with EPD Hub, this program operator that I mentioned earlier. On the One-Click LCA platform, you can create the EPD report, and with one click of a button, it can then be sent to the EPD Hub portal, where it can then be assigned to a verifier. And once the verifier is happy, it will automatically be published. So it's a nice streamlined process that covers all of the four main stages of generating an EPD. So I mentioned the partnership that we have with One-Click LCA. That's just part of our Recolight LCA service. I also want to highlight other aspects of our LCA service. Sorry. So there's kind of two sides to our service. One is kind of education, the other one is support. So education is in the form of webinars, much like this, but also in the form of training workshops. So these are kind of day-long workshops in person in a kind of roundtable environment. I ran one a couple of months ago. And these are to go into more depth about the regulation, the standards, data requirements, the verification process, and just generally providing a platform to ask questions, interact with others that are in the same boat, and just get an idea of the whole process that's involved for the EPDs. I haven't picked a date for the next workshop, but it will be probably in the autumn. There's a form that you can fill in on the Recolight website for an expression of interest. We've already got a few names down, so just go onto the website and have a look, or email me, and there'll be an email at the end of this presentation, just to express interest, and we can put your name on the list for that workshop. We also have EPD support. This is what kind of one side of the EPD support, and this is using the One-Click LCA platform. As I highlighted on the previous slide, this is kind of the streamlined process that is the reason that we kind of partnered with One-Click LCA. And we can provide access to this software, provides software training and ongoing support throughout the EPD generation process. Now, realizing that there are different needs from different manufacturers, particularly in the lighting industry, Recolight are very excited to now offer this new one-off EPD service. This is a brand new EPD service, which is supposed to provide a nice stepping stone into the world of EPDs. It's a process whereby you, the manufacturer, will provide the data, and we will essentially do the rest. So we create the LCA model, we generate the EPD, get it verified, and we will then return a complete EPD to you. As I say, this is supposed to be a nice stepping stone, and it's perfect for getting your foot in the EPD door. It's designed to be accessible and a low-risk entry point into EPDs. But it could also be beneficial for any manufacturer that only require a small number of EPDs, that doesn't want to commit to anything long-term, because I know they've only got a small number. Or it's ideal for any project, any EPDs that are required on a project-by-project basis. So you can just see Recolight as an extra resource that can be involved for EPD generation. And this service is for £7,000 for EPD. We think, well, we know that this is a very competitive price point, and we hope that it can help encourage more manufacturers to kind of get their foot in the EPD door, and it's just an alternative offering for them. So yeah, very excited about this and being able to offer it to the industry. So the one-off EPD service is a couple of stages to it, and I just thought I'd highlight that now in the next couple of slides. And I'll break it down per stage. So to start with, once you've got in contact with us, we can have a scoping call, not least to determine your EPD needs and understand which of your products require an EPD. Then go through the data collection process. I'll talk a little bit about this in a second, but I will give more information as to what information is required, what data is required, what format it needs to be in, and we'll have an understanding of who's going to do that data collection process. And I will recommend that to include multiple SKUs. So trying to get a product family included in the same EPD, much like I've got a screenshot of the original EPD that I was talking to earlier, where they've got a different products that have different masses and therefore have different manufacturing A1 to A3 impacts. So we'll be looking to create a scaling table much like this. Also wanted to add that at the data collection stage, Recolight can offer you can commission Recolight to be involved in that stage as much as you like. We can be completely hands-off and tell you what data is required and how you need to collect it, or you can have us involved in that whole process as well. That's what we'd have a discussion about at the outset. The next stage would quite literally just be to agree the product that we're wanting to work on, or in this case, agree the reference product. Agree the reference product that we do the core calculations on, and then have an understanding of the family of products that would then be captured in the scaling table as well. The next stage will be the data collection stage. So this is to in this case, populate an Excel spreadsheet. So spreadsheet that looks much like this, where we're looking for all the different input and output flows, as I explained in an LCA model. But to give a bit more context to this, I think we want to think about the data that's required in any sort of LCA and any sort of EPD for luminaires. And so kind of going back to this product life cycle, going from raw materials through to end of life, understanding all the inputs and all the outputs. And just to give you a flavor of the sorts of inputs and outputs, as I mentioned earlier again, it could be the luminaire materials, the packaging materials, machine maintenance and water, but also the transport from their origin to the manufacturing site. So that could be data such as the distance and the type of travel as well. So that once it gets to the manufacturing site, we'll then have a good understanding of the electricity, gas, heat, any sort of energy that's required, and any production losses that are created. Ideally, this sort of data is covering around 12 months worth of manufacture. And with that, we can have an understanding of the nature of the sort of customers and how far away they are, and the sort of transport that's involved in distributing those products to your customers as well. At this point, this is the kind of the handover stage where it will then be handed over to the customer. And so the use phase and the end of life stages, they're a slightly different form of data. Not least in that if we split the kind of life cycle in half, we have what I have kind of called real data. So that's the 12 months worth of data on the left-hand side, versus scenarios. And so when we're thinking about life cycle assessment and therefore EPDs as well, we're thinking about the intended life cycle of a product. We know that it's beyond the control of the manufacturer as to how the product is used, but we can give kind of an intended life with scenarios that use data that's based on real-world averages and evidence. So the use phase and end of life phase, that's something that decisions that can be more embodied embedded in the LCA model itself. So I'm more concerned with the real data on the left-hand side. So that real data, as I say, will then be used to populate an Excel spreadsheet. And that's what either you, the manufacturer or producer, will do, or will do together. And then I will then use that data to create the LCA model. And all doing this using the one-click LCA platform. So information that's provided in the Excel, I'll use to populate the model accordingly. From that, we will generate an EPD document, and that would look something like this. And I would then send that back to you guys, the manufacturer, and you can check the EPD document and the LCA model if you like, and make sure that everything looks to be in order. Excuse me. Once you're happy with that, the final stage is then for me to then send it off for verification. So we'd send it to EPD Hub, who will then assign a verifier, and they do all the legwork at that end. And they will then look through the EPD that I have sent them, that we have sent them. And once they're happy that it complies with the relevant standards and the program operator's own rules, they will then give it a third-party verification statement. So this will always be found at the end of an EPD from EPD Hub. And there we would have it. That would be the process for creating a one-off EPD. Once it's been verified, it's then published, and the EPD is ready to go. It'll have an EPD number and it'll be registered. So that's kind of all I wanted to kind of highlight today in today's talk. And so I just want to recap with 3 main points. The first point is that an EPD can be more than just one product. You can capture a family of products. The rules around that kind of vary by program operator, but broadly, if they're in a family, then you can more or less capture them in an EPD. But that's a conversation that you can have early doors with the consultant or the program operator that you're working with. Recolight is here to provide EPD support where we can and education, so not least in the fact that we can provide access to the one-click LCA platform and provide training and support when you're going through the EPD process. And thirdly, today that we're really excited to showcase our One-Off EPD service, whereby you give us the data and we do the rest and provide a really nice stepping stone into the world of EPDs. So with that, I will thank you for your attention. I'm going to leave my contact details here, or the contact details of our LCA team. So that's lca@recolight.co.uk. If you've got any questions relating to any of what I've said today that cannot be answered today, then just throw us an email. If you're interested in the workshops, you're interested in these any of our services, get in contact. But otherwise, I'll thank you for your attention, and I will pass back over to Ray to potentially take some questions.
Thank you, Max, for that very thorough presentation. I can invite Nigel, if you could join us as well, that'd be great. Yeah, and Nigel, you see clearly APDs as you know, a growing piece of the radar and piece of sustainable lighting.
They are. I mean, if we think back just 5 years ago, the only sustainability requirement on any sort of tender or specification was energy efficiency. And obviously, energy efficiency, as Max pointed out, is still absolutely crucial, because actually it helps to reduce carbon emissions. But we're now moving beyond just energy efficiency to having a number of other sustainability criteria that end users are looking for if they, prior to purchasing equipment. And arguably, the further down the road we get to decarbonizing the grid, the less focus there will be on not just energy efficiency, but on the other metrics as well, because they will become increasingly important. So it's remarkable how quickly the industry and specifiers in the industry have started to change and pick up on this.
Mm-hmm. I mean, it is extraordinary how quickly, TM66 and TM65 got adopted. So there's clearly, a need and a want out there, and they were, very rapidly adopted. So, but EPDs and are on a different scale, aren't they, in terms of the depth that they go into?
Very much so. I mean, and TM66 is slightly different from an EPD, really. It's looking at different things. I should notice we had a question from Mike Edwards on that, didn't we?
Great question. Yeah. Have you noticed any link between scores using TM66 versus the LCA, or can you result a lower score on one and higher on the other due to different parameters? Max.
No.
So presumably we're talking about TM65 in this case.
He's saying 66, but I mean, I presume you could extend it to.
Well, I mean, I can't say that I've noted any specific kind of correlation in any sort of way, particularly with TM66, and that's more of a circularity concept whereas TM65 is much more of an actual metric.
For embodied carbon, yeah.
For embodied
65
carbon,
is embodied carbon.
TM65 being embodied carbon. There's naturally going to be a relationship between the two, and they're two different methodologies that are trying to obtain some sort of carbon footprint associated with the manufacture of those products. It's It's been shown in Circular Lighting Live. We had some talks. I think it was just last year, comparing TM65s and EPDs, and showing that there is a difference in the two methodologies, which is essentially why those two methodologies cannot be compared. You've got different assumptions that are embedded into TM65, which are kind of fixed to an extent, whereas in an EPD, using the LCA methodology, you can afford to be even more accurate because you've got the flexibility to change the scope of your study and what have you. A good example is if you think about the end of life stage. I think TM65 just assumes a certain amount will be recycled and a certain amount will go to landfill of all products, I think, of all materials, sorry. Whereas in an LCA, you have the capability to break it down per material that's in that product, and you can say, well, these plastics may well go for incineration because the average European end-of-life kind of waste process is that a certain amount of plastics will be incinerated. That incineration in itself will create more CO2 than if you didn't incinerate it. And so that would then look potentially worse on an LCA than it would from a TM65 perspective. But having said that, that may look worse in that instance, but there may well be various other instances where an EPD will be a lower footprint because you've got less of a fudge factor involved because it's much more detailed. I don't know if that answers Mike's question. I feel like I might have gone off on one, but there's lots of intricacies involved is what I'm trying to highlight.
Yeah. Well, it can implicate. Oh, sorry, Nigel, go on.
All I was going to say was that I think if we're talking about TM66, there is not necessarily any particular correlation between TM66 and what you might see in an EPD, except that the companies that are producing products to a high TM66 score are probably also the same type of companies that will be considering carefully what might go into an EPD and maybe moving down the EPD track. But other than that, they're really different animals, aren't they?
So,
Yeah.
so you're saying a manufacturer who has, spent a lot of time and effort in terms of end-of-life disassembly and having components that that contribute to circularity are not going to be rewarded in an EPD, Max?
Not directly, no. So without trying to go into too much of the technicalities, you may well have those BDIs that among the audience may well have noticed when I was explaining the EPD table, I missed off the last column, which was column D, and that's to do with beyond the system boundary, and that's an actual measurement of the impacts associated with what's going to happen to the materials at the next kind of stage of its life beyond the life cycle of being used within a luminaire. So if you think about for example, let's say you've got a steel component in your luminaire, you run through the life cycle assessment for the inclusion of that steel component in your luminaire, and then you'd hope that at the end of life, that steel component can be easily removed and then it can see a second life. That second life, whereby it's no longer a virgin material that's being used, you can then work out the benefit of not using a virgin material, and that's what that D column is. You could argue that metric is then aligning with the circular principles, but it only goes to a certain degree. LCA is very much looking at the processes from quite a linear perspective, and so looking at a TM66 and an LCA, they often disagree with each other. Because you may well have a component that you say, well, I'm going to actually make this component out of steel because I know it's going to last longer, but the embodied carbon is going to be worse than if I was using plastic. I'm using quite a dramatic example. So it's quite often that it's one or the other. And we don't yet have a system in place, not just the lighting industry, but I'd say kind of the built environment and kind of all building and construction products. There's no gold bullet to be able to say, well, this is more sustainable. It's going to be, well, this is more sustainable because it lasts longer, but this is more sustainable because it can be used multiple times. There's loads of different aspects that you need to think about.
But that's not taken into account in the EPD. So
no, it's very hard to capture all of that in the EPD. It's very hard to capture that in just a table at the end of an EPD because you need to think about the scenarios involved as well.
So if you use recycled aluminium instead of virgin, you must get better numbers on an EPD, no?
Yeah, so you will get better numbers. You'll get, well, as long as you're using recycled aluminium that's recycled in a way that is more sustainable than if you were taking virgin, because it's not always a guarantee.
Hmm.
But yeah, that will mean the embodied carbon within the product will then be lower if you're using that. Um, and then, but equally, if you've got aluminium that you know that you can send off that can be
Yeah,
used
yeah,
for second
yeah.
life, that can kind of be captured as well. But it's not quite as easy to. Um, I don't want to say that a big number necessarily on the EPD means that it's more circular. There's not necessarily that correlation that we're looking for.
Hmm. And so if you reuse a luminaire, which had previously had an EPD, do you get any is there any sort of way you can um, receive the benefit of reusing a luminaire? Let's say you've upgraded, remanufactured a luminaire, put in an upgraded LED module, etc.
Mhm.
Would that be
So
reflected as an EPD?
this is one of the limitations in that there's no, as far as I know, there's no kind of standard that says if you've got a product and you're giving you're maintaining it in however way, you can't then use that EPD. You'd have to just take the information that you have as the remanufacturer, in that you've taken a luminaire and you've gone through the process that you needed to recreate it. You'd need to do the EPD yourself again. There's no standard that says, right, this is how we're going to measure the remanufacture process from an EPD perspective.
I mean, arguably, the the embodied carbon of the luminaire has already basically been written off, and so by
Yes.
definition, at least the embodied carbon should be a lot lower, and so that should result in some better EPD scores in there.
Mhm.
But it won't,
Absolutely.
according to the rules. I mean, yeah, if you had a luminaire that had lived its 50,000 hour life and you reused it in some way, you would have to start again and use the original numbers.
There's no as far as I'm aware, there's no kind of and I've never done that before, so there's
Yeah.
no standard that kind of dictates how you would go about that. I want to highlight here that an EPD is the best metric that we have out there, but it's not going to cover everything. One thing that I've mentioned in the workshops is it uses the LCA methodology, and the LCA methodology is probably the most complete methodology and kind of academically informed methodology that we have to create these metrics.
Hmm.
But it doesn't cover everything. As I say, you've got lots of different impact categories that an LCA can calculate for, and that carbon footprint is the one that gets the limelight. There's a string of others, but it's not going to capture everything. One big talking point in the LCA kind of practitioner community is the fact that we have no agreed methodology for calculating the amount of microplastics that are associated with using certain types of material. Even though we know microplastics is an issue, we don't have a mutually understood way of academically calculating at the very, very kind of um, back end, sort of the the calculation as to how we're going to go from this amount of plastic is used in this product. How do we convert that into this much microplastic? That conversion process has not yet been agreed. And so it's not going to cover everything. EPD is not the be all and end all.
Hmm.
It's a fantastic tool, but we need to think about EPD and circularity at the same time and not necessarily think that EPD is going to be the be all and end all to cover circularity too.
So TM66 and EPDs are complementary, really, and
Yeah,
yeah, and
yeah,
yeah. Okay, fine.
yeah.
So Mike Edwards is saying thanks. As I wonder if manufacturers will focus on marketing the higher score only, whichever calculation method produces that, and will end users understand the different scales? Well, there's two elements there. First of all, um, manufacturers are clearly going to use numbers that flatter them, I imagine. And the question we obviously need to come to is, will end users understand the different scales, and will the numbers resonate and have meaning?
I,
So I
th I
think,
think, yeah,
sorry,
go on, Max.
you go, Nigel. No, you go, Nigel.
Okay. All I was going to say is that I think at the moment, um, specifiers and end users as a sort of asking, what data do you have? just give me what you've got. And if you've got a TM65 or 66, that's great. But if you can go further and you've got an EPD or an LCA, so much the better. But at the moment, that's where it ends. I think what will happen fairly soon, driven in various ways, is actually they'll start to interrogate what that data is. So it won't be as sufficient just to say, tick, yes, I've got an EPD. It will be actually, let's look at the data and we'll start comparing products that are obviously on a relatively like-for-like basis, and going for those that have got a range of better scores. We're not there yet, but I think we'll be getting there fairly soon.
Mm-hmm.
And to add to that, I think when we're talking about the scales that are involved, when we think about TM66, which is a scaling kind of process, TM65 is more of an actual number. EPD and LCA is a number. This is the amount of carbon that we have estimated or calculated to be an estimate for the amount of carbon that's released from the manufacture, the use, the disposal, etc. of this product. And so that's the actual number. Whereas with TM66, it's a scale. And so that's two different metrics that we need to, that those two numbers are completely incomparable. So I just thought that was worth highlighting as well.
Well, I suppose the genius of TM66 is that, companies can say, as I see Appalech are saying, we have 2.7, we will score 2.7 for our product and it's excellent. So, it's great like that and it gets traction, it drives education. So, I'm a bit of a fan of it. I like the simplicity of it.
Yeah,
Question
absolutely.
from Irina Matsai. Hi, Max. Thank you for your presentation. I would like to ask a question regarding your one-off EPD assessment. How is the scenario-based data dealt with? Do you apply a standardized set of assumptions, or is it a case selection of scenarios? Thank you.
So it's so using the one-click tool. So we use the Luminaire tool, and the Luminaire tool has embedded in it assumptions that are based out of PSR14, and it's all assumptions that are based on an integrated LED luminaire.
Do you want to explain PSR 14?
PSR 14 is a set of product-specific rules that are that the LCA practitioner would want to follow if they were to try and. They're the most complete set of rules that can be used for luminaires, basically. In that if everyone followed them, it would make luminaire the results from a table of the results table from EPDs more comparable between EPDs, and so they're a really nice complete set of rules. So the one-click LCA luminaire tool, which is what we use for this one-off service, uses the assumptions for integrated LED module kind of scenarios, particularly for the end of life scenarios and impacts associated with it. I think could you remind me the question? I think that kind of.
Yeah. Do you apply a standardized set of assumptions, or is it a case of a case selection of scenarios?
So it's that specific scenario is for the end of life. When it comes to the use phase, oh no, not the use phase. Use phase is easier. That's as far as I'm aware. It's basically one scenario that's kind of pre-formulated, if you like. So from the user's side of it, beyond the handover point, pretty much all the scenarios are preset.
So it is a standardized set of assumptions.
Yeah.
Yeah. Okay. So when we're using EPDs and when they get out in the market and the specifiers are demanding them, what does good look like, and how would you know?
That's a really difficult question to answer.
Yeah. Sorry.
As I say, you may well want to create an EPD so that you can get the lowest carbon footprint you can, and that's fine. You could just not produce the light at all. Or you could produce a light that draws no energy. You could produce a light that draws 1 watt. There's loads of ways around it, but it's very, very difficult to say what isn't a good EPD and what is a bad EPD. It's very scenario specific as well. Drawing a comparison between two EPDs, this is Irena's one that highlights this a lot in her talks, which and is really good at communicating the fact that if you've got two EPDs, you need to make sure that there are so many factors, including that EPD, that allow you to draw a comparison between the two. Not least in that you're probably using the same rules, for example, you're following the same standards. Ideally, you'd be using the same back-end databases as well. There's lots of things that you need to think about, and so trying to find a good EPD is very difficult. Not just because of that, but you also may have two EPDs that are comparable, but one is definitely trying to target a circular economy, and the other one is trying to target the lowest embodied carbon as it possibly can. So well, it's an impossible question to answer.
Yeah, because I mean, do you think in the future benchmarking would emerge? So you would be able to say, right, I'm about to specify 5,000 bulkheads, and this is what a sort of bulkhead, an 8-watt bulkhead should look like, kind of thing. Was that a fair?
Yeah, well, yes and no. I think I know that. Well, to start with, I feel like the industry is such an early stage now that there's not enough kind of published EPD data out there for us to actually make any sort of, not yet a comprehensive understanding of what a bulkhead looks like in the form of a carbon footprint or a linear or XYZ. There's work by, again, Irena and the Greenlight Alliance to publish some industry average EPDs for specific lighting products. I don't know what the update on that is at the minute, but that's really useful in that it gives you some sort of point of reference. But ultimately, when we're looking at kind of building frameworks and standards to fit out offices and for the UK net zero carbon building standards, they're eventually looking at a number that they want to get under, and it's probably a number per square meter, and all the products that then go into that are then going to be involved in that calculation. So yes, ultimately, that's the way things are going. I don't know the timelines on that, and I don't know how those calculations are being made. I've never been involved in any of that sort of process, but yeah, that's ultimately where the direction of travel.
Well, presumably they would plug into building information modeling things, Revit, and all that would handle that, I would imagine, and then you could a number pops out at the end. I'm imagining. So tell me this: what are you finding the biggest challenges that lighting manufacturers have with EPDs? Is it gathering the data?
Yeah, definitely. It's gathering the data. Gathering the data, make sure it's the appropriate data. Having done one-off EPDs already, I've been in contact with suppliers for our clients, and I've said this is the information that we need. If you've got an EPD, then that's great. That's we're halfway there, because I can draw the information from a components EPD and draw it straight into a luminaire EPD, and they say yes, we've got an EPD, here it is, and they send it to me, and it's just not an EPD. It's just a document.
Really?
They've put EPD at the top of the document, and then they've done something. Yes, yeah, absolutely. But they think this is an EPD. And I have to say to them, I have to politely inform them that's not what an EPD is. You've also got the fact that there may well be companies that have got an EPD, suppliers that do have EPDs, but they're based in America, and so they go by American standards. But we're producing EPDs that comply with European standards, and so there's another point of difference there. And so having those conversations early on to know, okay, these guys have an EPD, but it doesn't necessarily fill our need. We're going to have to work around this. Is a good place to start. Now I've been saying to manufacturers, if you can start to collect your information now, engage with your supply chain. Just say that we're going to be needing this data at some point, and this is the format that we need it in. Then that's the first place to start, because that's what you're going to have to do once you've got your consultant or your software or whatever that's going to be requiring that data. So there's no harm in collecting it now. And I know that there are probably manufacturers out there already that are thinking about the TM65 methodology, and they think, well, if we engage with our supply chain now, we can then potentially automate TM65 generation. There's no harm in going one step further and making sure that you've got the data that's sufficient for the EPD as well, so that when the time comes, you have that data ready. So yeah, the data collection side is definitely it's the first thing that you're going to have to attack, and it's probably the hardest thing that you'll have to attack as well.
But presumably the big brand suppliers, let's say you went to Tridonic and said, what is of this particular piece of gear? Have you got the numbers that I need for my EPD? They would have that.
Yeah, I mean, it's easy to assume. There are lots of players in the industry that already have their EPDs, and yeah, the big guys are more likely to have them. We know that. It's the same for the actual luminaire manufacturers as well. But even then, you have to make sure that some of the big guys may well have been engaging so early on that they're complying with an old standard. Tridonic, they were working to one of the previous standards, so they've got EPDs that are comply with an older standard. So if you're making an EPD now, you have to ask for them if they've got an updated version. So it does get quite complex, but yeah, as I say, engaging with the supply chain as early as possible is the way forward.
And what would be the biggest influences on your EPD numbers then? Is there one sort of item? Because I'm always surprised at how little transport. We talk a lot about transport, getting things in from China and all the rest of it, but it doesn't move the needle so much on numbers, actually.
No, not necessarily. I mean, the biggest impact is the use phase. There's no beating around the bush. The use phase is always going to be dominant, and so that's why we're always looking towards where the point at which the grid becomes has more and more decarbonisation. But aside from that, if we think about the embodied carbon, it's always the impacts associated with material selection and the processes involved at the manufacturing site that are going to be the hotspots. That's nearly always going to be where you're going to be, your attention is going to be drawn to when you look at the results at the end.
Yeah, but as you say, as the grid decarbonizes, and it is decarbonizing quite speedily, really, the embodied carbon will become a bigger part of the pie chart, won't it?
Exactly.
Yeah, and which is why we're looking at this. Okay, well, I think we'll wrap up there. Thank you, Matt. There's a lot to unpack in these EPDs and LCAs, and well, I think standards and norms will emerge, but we're still in the kind of foothills of it, aren't we? I suppose.
Yeah, absolutely.
Yeah. Good. Okay, just a reminder that at Circular Lighting Live in 25th September, you're going to be giving a talk, Max, aren't you? Diving into this and how would specifiers use EPDs, compare them, etc., and all that type of thing. So you're going to give a slightly different talk there. But again, we look at the first version of TM66 because it's currently in beta mode, and so we'll get an update on that from Christina Allison, and we'll also look at the IALD development of its LCA. So that's all on Thursday, 25th of September at the Minster Building in London. So we'll see you all there, and that reminds me to thank Nigel and Max for your insights and your discussion today.
And thank you, Ray, for chairing, and Suzanne for doing all the background tech as well.
Yes, of course, Suzanne behind the scenes. Thank you, Suzanne.